Hey guys, welcome. This is your 10.3a video, so let's get started. 10.3a, we are talking about regular polygons, and we need to write this stuff down. So, what I'm about to highlight here, we need to write all this down. So this whole paragraph, yes, and this whole picture, kind of everything basically in this box, we need to write down, okay? So let's go over this real quick as you guys are writing this down. Basically what we see here is we are finding a regular polygon. Regular polygons are any sided figure, but all sides are congruent. What's special about a regular polygon is that it fits within a circle. So if you can see our picture, we have a circle going all the way around this regular polygon. All the vertices here hit it, which that's why we call these a radius from the center. And we have this special word called a apothem. An apothem is a perpendicular distance from the center to the side. So it goes from the center perpendicular to a side, and then these guys are called the radius or radii if you're talking about plural. So you can circumscribe, that means draw a circle around any regular polygon, and the center of the regular polygon is the center. The radius is the distance from the center of the vertex, and our apothem. So this is huge for us because we're going to be using this thing apothem in our equation to solve. Like I said, all we're doing is finding areas of shapes and regular polygons. This will apply for a lot. So let's go ahead and flip over to this piece, and here we have our equation for the regular polygon. The area of a regular polygon is half the product of the apothem times the perimeter. So if we do the apothem times the perimeter, that's the distance all the way around the shape, we're going to get our area. Okay, this is not easy to do. There's a lot of things that can get very tricky, so we're going to break this into little segments to make it easy. So first thing, let's just go ahead and find our area using this formula. The formula itself's easy. The hard part is making sure we do it right. So what's the area of a regular decagon? So we've talked about some shapes before. A decagon is going to have 10 sides. So what we want to do is we just want to use our formula A equals 1/2 AP. Now P stands for the perimeter. So perimeter in a decagon, all of these sides are congruent. Okay, so we have 10 of them, and their side length is 8. So we just have to do 8 multiplied by 10, and we're going to get our perimeter of 80 inches. So we're going to use that, 80, and then the distance from the center perpendicular to the side is called our apothem. So this piece right here is the apothem. And make sure you label everything and write everything I'm writing down. So here's our apothem. And so we just have to plug in 12.3. And we take 1/2 of that. So, not so bad. We just plug this into our calculator. So we grab our calculator. And we do 12.3 times 80, and then we take half of that. And our answer becomes area equals 492 square inches. Again, we're still talking about area. It's of a regular polygon. You should be able to do that easily. I have all the information. Really just kind of had to find the perimeter, which was pretty simple. Multiply the side length by the number of sides, in this case 10. So you should be able to do that in case we have a quiz tomorrow. Booyah. Okay, let's move on. Let's take a look at a more difficult problem. And I don't want you to write this one down yet. We're going to go ahead and come back to this problem. I just want to take a look at it. Okay? So here we go. Given, let's just pause it right there. Given this picture, could we find the area of this hexagon? And at first glance, I don't know the apothem, so I could find the perimeter, but I can't find the apothem, or I don't have the apothem, so I can't use my formula. So what we're going to have to do is we're going to have to do a little bit of work. So we're going to come back to this question first. Let's take a look at how we could find some angle measures, because there's technically some triangles involved in this. So let's take a look at some angle measures. So this is our second example we are going to do. And here we go. So it wants us to find the angle measures of 1, 2, which is inside here, and 3. Okay. Do you see how this pentagon is broken up into 5 different triangles? Okay. Now, we did a while ago the interior angle. So we can find the interior angle of this triangle. Now, remember, a circle is going all the way around this, and there are 360 degrees in a circle. And notice it's broken up into 5 parts. Okay? Oops, that was not 5. 1, 2, 3, 4, 5. There we go. So, to find the interior angle, all we have to do is divide it by 5. So, we can take 360 degrees, divide it by 5, and that's going to give us what we call the central angle. I'm still sick. So divide by 5, and we got that central angle, which is going to be our angle 1. So 360 divided by 5, and we get 72 degrees equals angle 1. All right. So that's our central angle. Let's leave that information right up here, and we'll call it 72 degrees. Okay. All right, so we found our central angle. Because it's a circle, we can break it up and divide by 360. So 5, because there's 5 sides. If it was a hexagon, we divide by 6. If it was an octagon, we divide by 8, so on and so forth. Okay? So boom, 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 boom. We got that. Next, we want to find angle 2. To find angle 2, this breaks our angle in half. So we're going to take angle 1, and it's not technically equal to angle 2. It is equal to half of angle 2. Okay, so if I take angle 1, divide it by 2, if I take angle 1 divided by 2, I get angle 2. So if we take 72 and divide it by 2, that should be our angle. It bisects. That apothem bisects our central angle. So we divide by 2, and we get angle 2 equals 36 degrees. Okay, we're almost there. Erase that off. All right, and here we go. Now let's go ahead and draw this triangle, and I'm going to draw it in the appropriate way, so it's kind of facing up to us. So here's that dashed line, here's a 90 degree right here. Okay, so the whole angle is 72 degrees. The partial angle right here is half of it, which is 36 degrees. And now we're trying to find angle 3 down here. And the way we're going to do that is just subtract. So do 36 plus 90. Got my calculator over here. And we get 126. And subtract that from 180. And angle 3 is equal to 54. So you might be saying to yourself, Mr. Smith, why do we care about these angles? The reason why we care is with angles, we can find the length of the apothem. So we didn't know the apothem, we can now find it. So let's go ahead and take a look at our example we looked at a second ago, but now we can find some angle measures. So I'm going to go ahead and clear this, and we're going to look at our last problem. Boom, ba-doom, boom. Boom, ba-doom, boom. Boom, ba-doom, boom. Okay, that was pretty fun. We already did this one. I didn't mean to pick that one. I meant to pick this one. My bad. And we're gonna let's get that picture back up here. Ba-dum, ba-dum. Boom. Okay. So here we go. Step 1, find the apothem. My face will cover that up. So we have a hexagon here. So remember, our formula is A equals 1/2 apothem times the perimeter. So we should be able to find the perimeter. The perimeter is going to be 3 times, okay, 3 times, and we want the amount of sides, so that's going to be 6 different sides, so we get 18. So we have our perimeter. So we're good there. Now we need to go ahead and find the apothem. So you can actually make this into a triangle. Boom and boom. Now we need to find this angle in here, and if we can find that angle, we be styling. Okay? So how are we going to do this? Well, we have 360 degrees. It's 6 sides. We need to find the central angle. And to find our central angle, we can go ahead and do 360 divided by 6. Okay? And if we do 360 divided by 6, we're going to get 60 degrees. Okay? So, let's draw in some other triangles here. So that means this is 60 degrees here, 60 degrees here, 60 degrees here, so on and so forth. Remember, the apothem, though, cuts it in half. So the apothem is going to create this angle right in here, the small angle, to be half of 60, or 30 degrees. Well, we've just created a special right triangle. Because the apothem is perpendicular, we can draw this triangle out here. So here's the apothem. We found this angle, half of the central angle, to be 30 degrees, and we know this is 90. So this has to be 60 degrees by using triangle angle sum theorem. Alright, still don't have enough information. Now a side length is 3. The apothem also cuts this in half, so we get 1.5 for this side. So if you divide 3 in half, you get 1.5. So what's the apothem? Well, it's in the x position, so it's going to go over here, and we're going to put it into the x rad 3 position. So our apothem ends up being 1.5 rad 3. Okay? Seems kind of difficult, kind of confusing. That's why you kind of got to watch this a bit. So we have our apothem, we have our perimeter. Now we just go ahead and solve. So we get 1/2 1.5 rad 3 times 18. Okay? So the whole numbers multiply, so 1.5 times 18 equals 27 rad 3, and then we take half of it. So we end up with 13.5 rad 3, and this is going to be in millimeters, squared millimeters. Alright, that, my friends, is a difficult problem, and we're going to spend a lot of time working on this problem. Okay? Finding the apothem, it's really just doing special right triangles. And then we're eventually going to see we might have some non-special right triangles, and we'll be doing some with trig. But that will be next day. Okay? Alright guys, this is Mr. Smith, signing off.